Is it case dependent? EPA is all county PA? Is that it? It says county.
And it's not going to be where it falls asleep, right?
We'll try not to.
Because
If not, here's the password right there.
I've had trouble here with it falling asleep.
I know, that's why we put the password on this computer, so
Yeah.
and then during the meeting, so we don't have to disturb everybody, put them on here so people can just
Yeah, but there's also, well, okay, there's also a way of coding it.
Is this the one that's...
Because things kind of, yeah, I've had some bad experiences.
I'm basically relearning stuff. Oh, some things have changed too.
Are you going to spend a little bit more time here?
Yeah.
Oh,
Yeah.
he's here now permanently.
oh, you're here now?
Yeah. Just today. Yeah.
So they reassigned you?
Yeah.
Oh, okay.
Yeah, I think Rachel is going to move.
Yeah, she moved to Oregon.
Oregon. Yeah.
Oh, I see.
So, yeah, it's good for me. It's more steady.
And you could see all the environmental problems we're having.
Yeah. Makes you feel good. Any requests for camera work? Is
Yeah.
it going to be a group all filled up there? Or
So
just certain
each presenter is going to speak from the podium,
Okay.
and then during the Q&A, they're going to be taking the tables.
Okay.
So it's pretty straight up.
Yep.
And normally it's like 20 seconds on the speaker, 80% on the slides.
Right.
Got it.
So it's what you guys have known from me saying 2080. Yeah.
Right here, so, right here.
Okay.
That's where it's.
This is the one that's just Cali.
Yeah, it's County PA / capitals. Capitals,
So the webcasting is going to start immediately.
It's already
It's already going. Okay. Okay, and then you're going to give me the web feed. So normally the monitor will have the address, so folks
Yes.
can see the address. Very important.
It'll be on all the time unless it's covering up part of the slide.
Yeah.
It's just that we had.
It's probably better to put this on now.
Okay. Happy to do it.
And you put that right, yeah, very good. Yeah. That's probably good. Yeah, I'd say that's good. And then I'll call you by your last name. You don't want me to do that, or normally I do that. Dr. Particular. And then I'll hand you the mic. I'm only going to tell them, safety things like exits and restrooms, and then I'll mention that we encourage folks to send in their questions Q&A at first opportunity so we could have time to take it on the air. And at that point, I'll just hand you over the mic. Okay. We're about to start momentarily. We're just dealing with a few items that we're still trying to clear up, but we're supposed to start, I'd say, pretty soon. Thank you. Thank you for your patience. Oh, you're trying to get the feed? Okay. You should say, oh. Where's the feed? Oh, down. Oh, okay. Yeah. Right. Okay. Okay. I'll take it there. And you're saying that we're already starting the webcast? Oh, I'll take care of that stuff. Don't worry about it. But it's already up. So we could start now. And it's already, and you have the web address underneath.
Yes, I
You have, you don't have it on yet?
I did earlier.
Okay. Okay, make sure, yeah. So we're about to start. But before we do, I just want to let folks know that are in the auditorium to note exits in case we need to leave the room on short notice. Also, restrooms are on the I Street side of the lobby just behind you. And before we do begin, we encourage folks on the internet, if you wish to have your questions taken for the Q&A, please send them to the address that you'll see on the bottom of the monitor, coastalrm@calepa.ca.gov. Send those as soon as you're able so that we have time enough to take them for the Q&A and not leave your questions unanswered. With that, Dr.
Great. Well, I'm glad to see such a big audience. We're very excited about the presentations today. We have 3 presentations, all on behavioral research at ARB. The first presentation will be on the results on how real-time energy information can induce energy conservation behavior. The second project will provide results on how educating households on energy pricing schemes impacts residential electricity consumption. And then the third presentation will provide information on the behaviors and attitudes of low energy users in California. And the results from these projects can inform IOUs and decision makers about successful policies and strategies to reduce residential energy use. So why focus on behavioral energy use in California? Well, we have several pieces of legislation in California, which I'm sure you're all familiar with, but AB 32 to reduce greenhouse gases to 1990 levels by 2020, and then also the executive order to get 80% below 1990 levels by 2020. And ARB, of course, is the lead agency for implementing AB 32 and they developed the climate change scoping plan to provide a roadmap to achieve these reductions. So cap and trade, advanced clean cars, low carbon fuels, renewables, S375, they're all important building blocks to meet our greenhouse gas reduction goals. And the 2008 scoping plan acknowledges that greenhouse gas emission reductions required under AB 32 cannot be realized without the active participation of Californians through voluntary action. And then an update to the 2008 plan will be available in the fall. In response to our agency's need to achieve the goals of the scoping plan, ARB has developed research projects to help create a variety of strategies, tools, and resources to support voluntary efforts. And ARB's research efforts related to behavior and technology focus on the built environment and transportation, both in the residential and commercial sector, which are collectively responsible for a major portion of both greenhouse gas and criteria pollutants. ARB has several current and upcoming research projects that will evaluate strategies to reduce energy use in commercial buildings and will explore household vehicle choices and transportation usage patterns. And understanding how factors such as social norms, economics, and values can influence decisions around energy usage, travel, and product consumption can help us identify strategies to encourage behavior in a direction that leads to greenhouse gas reductions. And there are several state agencies that are involved in behavioral research in California, ARB and Energy Commission, CPUC, and we meet regularly to make sure that we're not duplicating efforts and leveraging funds as much as possible. And also, of course, the IOUs are currently administrating a suite of demand response programs, and hopefully our research will help inform the implementation of more of these programs. And just to provide a background on residential energy consumption in California, the pie chart on the left shows that residential energy consumption is about 20% of energy consumption in California. And then the pie chart on the right shows that most of the energy used in a home goes towards heating and cooling of space. And then I worked for the Energy Commission, so I'm obligated to show this slide. But it's a great example of how California has benefited from energy efficiency policies and standards. And they've had a significant pattern on per capita electricity use over the last 30 years and have essentially stabilized it while the rest of the nation increased by over 50%. And while we've made significant gains in energy efficiency, we still have a long ways to go to reach, especially our 2050 goals, and many studies have projected that we need to reduce energy use by 43 to 52%. So there's still a long way to go, but we're sure that behavioral or energy use in the residential and commercial sector are important wedges to getting down to these goals. And if you want more information on the presentations today, the final reports from these 3 projects will be available online. We'll also have the archived videos from this presentation and the PowerPoint slides available on the seminar announcement. And then we also encourage everyone to sign up for our listserv, which will give you announcements about all of our research seminars, which are all excellent. And if you have any additional questions about today's presentation, feel free to contact me. My email's on the slide. And I also wanted to make a plug for tomorrow's chairs lecture, which will feature Matt Kahn. He'll be talking about his book, Climatopolis, which is looking at the impact of climate change on the quality of life and the economy in California. So I hope you can all make it tomorrow at lunch. Great. Well, our first speaker is Magali from UCLA, and I'll hand the mic over to her.
Okay, thank you. Thank you. So good afternoon, everyone, and thank you for coming. It's great to see such a big audience today, and I'm really excited to share some of the results of our research and learn more about what my colleagues have been doing at the same time. So I'm going to talk today about our Engage project that we've been conducting at UCLA with my colleague Bill Kaiser from Electrical Engineering. So our research is really trying to figure out how do residents respond to real-time information about their energy use. So with the advent of the implementation of smart meters, we will have kind of a lot of information available. Residents will have a lot of information available. And there's this question on what do people care about? What do they actually look at? And how do they respond to this information that is going to be made available to them? And in this specific experiment that we have been conducting at UCLA, we are looking at real-time appliance level information about energy usage and seeing how people respond to that information. So our model here is to say, well, you know, information is really important for people to change their behavior. And I think in relating to electricity, information so far has been relatively limited. People receive a bill every month, every 2 months. And this information, some people have said that it's kind of equivalent to going to the grocery store and you get your bill at the end of the month, but you don't really know if you're buying, if your eggs are more expensive than caviar, and then at the end you're just, it's more difficult for you to make these choices. So what if we provide people with this information about appliance level, data about their electricity usage to inform them about, how to reduce potentially this their electricity usage. However, you need people to care about that. So I think that's the second issue here. Not only you need to realize maybe that there's a problem that you're consuming a lot, that maybe your electricity usage has an impact on the environment, on health, on cost, but you need to care. So there's something about the incentive. What are the messages? How do you kind of frame the information so people look at it, understand it, and actually act on it? And so this is really, that's this chain of event that we're looking at. We're providing information, and we are testing different framing. Framing here based on environmental and health messages, and framing based on cost. And we're saying, what do people care about? And then we look at how they change their behavior, and we are actually observing their electricity usage in real time, and we're seeing which appliances they will turn off and on, or not. So this is our real-time appliance energy use. We are going to observe people and give them information about their heating and cooling, the lighting, plug load, dishwasher, fridge, and other kitchen, just a toaster, and things like that. We are going to test different messages. We're going to give people messages about their usage, and we're going to frame these messages in two different ways. One is going to tell people about their electricity usage and how much it costs them, and how much being like the most efficient in their complex would be saving them compared to what they are doing right now. So this is kind of what we say the cost message. We have this other message where we say, we really don't really know much about the impact of our energy use on the environment. We turn on our computer, we open our fridge, we turn on our TV. We have no idea on how much this impacts the environment. So let's give people this information and see how they respond to it. This is our kind of second framing. So we're comparing these two framings to providing no information about electricity usage to people. So we have an experimental site at UCLA. We're very fortunate to be able to work with the university here. These are 120 apartments that we have equipped with this real-time appliance level monitoring technology. These are apartments that are where married and partnered graduate students live. And they are with or without children. These are 1, 2, 3 bedroom apartments. The beauty of this site is that they all have the same appliances. They're renting. They have the same fridge, the same dishwasher, same size apartments. We can control for all of these things. They are located, as you can see here, the study site, point A, very close to weather station, which is really useful because we can control for the type of weather that is happening at the same time. And it's not too far from UCLA, so we can go there and know how traffic is in Los Angeles. So location is important. Closeness to the university is important. This is where it is located. this is our complex here on each side of the freeway, 405. This is where our graduate students live. Welcome to Los Angeles. And so what we've done is we've installed this energy metering system where we install, basically we looked at each of the circuit breaker panel, and then we are connecting this to a panel of meters and then a gateway, and we provide this information back to the users through a website. They can have that also on their phone, and we give them information about their usage compared to the most efficient neighbor, same size apartment in their complex, and we're providing them with information about the different percentage of the appliances, and we are also providing this main message about the either cost savings or environmental impact. We're providing them various ways to look at the information compared to other days. We're providing this real-time tool which allows them to see when they turn on one appliance, they can see if it goes up and down, and they can just learn from that. These are the two messages that we've selected. The first one is about the impact, as I mentioned before, about the cost of electricity. So in this case, it's say, you used X% more than your most efficient neighbor. This is equivalent to X dollars over 1 year. And then we have the second message, which is about the impact on air pollution. So we're telling people if you're used X% more than your efficient neighbors, this is like adding X tons of pollutants. And we tell them these correspond to, these have been known to contribute to childhood asthma and cancer. Okay? So we're kind of heavy on the health and environmental impact here. So we're just finding out which message is the most effective and what works. The website otherwise is similar. Everything else is the same. They get this real-time appliance information data, but we changed the message. So this was an experiment that was conducted over almost a year. We monitored first, and we had the first treatment when we start to send the messages. We also every week send a message by email. This is very important. Every week people receive an email with a message, and they can click on it and see they go to their website, or they can log to their website and see the information anytime they want. So we have a lot of information about when they go to the website, what they see. It happens that they actually go to the website when we send them the email. They respond to the email, and then they click and they look at the website. What we see on this graph is that people from the health treatment, people who receive the health message, tend to go to the website more often. You can see they are in orange here, than those with the financial message. And we stop here in June after people tend to go on vacation. So we see these spikes every week. They look at their email they look at their website when they get the email. Then we run some regression to figure out what message is the most effective. And we run regression at the total kilowatt hour and also by appliance. And so what we find here is that the overall savings from the blue group is 6% overall, or even 9%. So the savings from the health message are significant. What we do find also is that people who receive the financial message don't respond to it. They don't seem to be significantly different from the control group. So it looks like it doesn't really matter to them. So we do this beautiful website, we give them all this information, but we frame it in cost savings, and they don't respond to that information. On the other hand, they respond to the health message, and here what we find also is that households with one child or two or more children tend to be even more respond even more to the message, from 19.5%, 18.4% reduction for these specific groups of families with children. We have information at the appliance level. As you can see from these are 1, 2, and 3 bedrooms. We have this information that provides us with kind of this picture where the plug load is really important. Remember, we live in Los Angeles, it's not far from the ocean, so we don't need that much of heating and cooling, and that's why plug load is very important. Interestingly, the fridge was also a very important appliance, something that people didn't really think about before, and have been upgrading. We did the treatment by appliance, and so what we see is that people tend to reduce their lighting. Here, it's like in this column here. But really, most of the savings are going to be on the plug load. So they tell us they will unplug their appliances at night. Strangely, the fridge seemed to be increasing in both cases. We've been looking into this specific appliance, and it looks like the direction on how to change the settings are very unclear, and some people seem to actually not understand how it works. We have the daily load profile, so you can see how our students live. We have that for each appliance, and it seems, they wake up in the morning here, and then this is the peak load. They get their breakfast, around 9. Then they go, hopefully, to school, and then come back at night, and they work pretty late, I would say. And they wake up relatively, you could say 9. I always say, why is it difficult to get graduate students to meet before 10? And then I have the response here. They don't like that. Peak consumption is, at 9 a.m. and 9 p.m. So we have this, consumption by day. Most of the actual savings occur in the afternoon and the evening. So that's kind of something we learned also. What was also interesting is that we found some of the savings. So in here, the health group, those who received the message with the environmental and health, tended to respond, even those here in the 90th percentile, even the big users tended to respond to our message. However, those who were consuming most tended to even be less responding to the financial message. The financial message didn't work. Even some people tended to increase their usage, realizing how cheap electricity is. So if we look at the people who are in the 50th percentile, our message would tell them that they would save around, that is correspond to savings around $6 per month if they were like the most efficient, in the complex. And so $6 is like 2 gallons of milk. So it's possible that some people realize how cheap electricity is and decided not to, not to respond or even to, increase their usage. So these are some of kind of the, summary of our main experimental results. What we find is that the health treatment is more effective. It works particularly well for families with children. And the financial message was ineffective, and especially for high users in our context. The timing of savings, we found that savings are mostly at night, afternoon at night. And we did get some peak load savings in that case, although this is not what we were specifically searching for. And the types of savings were mostly on the plug load. So these are kind of the findings. We have a population which is very diverse, a population of graduate students. They get their electricity bill, so they're paying their electricity. They're probably more educated than the average population. And we think that this population is really interesting to study because they are those who are usually relatively familiar with using devices and looking at the internet. So it kind of gives us also some idea of how people in the future could use this information when it is made available. So the main results are that, I think I said that, environmental health message is more effective, 7% of the savings. And for the children, families with children, we even get to 20% of the savings. So the conclusion from this research is that the type of message that consumers receive matters. And I think it's important to see when we see a lot of companies right now investing in smart meter devices that provide this information to consumers, we need to understand what really works and what doesn't. And what we find in our case is that one message was really ineffective, even though we were providing, I think, quite useful information. We had some pre and post surveys when we asked people what they knew about electricity and what they didn't. and about appliance level. And most people tend to be relatively ignorant about what appliances really use a lot of electricity. And a lot of people were surprised to see, and I actually was surprised too, to see the share, for example, of electricity taken by a fridge. And so this education was, I think, was useful, but then was not enough to trigger conservation. To trigger conservation, you needed this additional message where you tell people, well, you know, there's an impact on health. And then this, where, you know, a population of people who thought they could maybe do something about it. So understanding the user characteristics also are important. We did find a big difference between families with children and families without children in our context. So they might, you know, might want to have messages that are targeted for different demographics, different messages for different demographics. So I think, you know, our research provides insight on how technology and information should be disseminated to maximize conservation. And again, our context was graduate students within, you know, I mean, UCLA graduate students. And what we would like to do is to continue this research and use different types of demographics, such as, you know, low-income populations, and see how the result would differ or not. We currently have students in India trying to figure out how we could expand some of that in a different environment. So thank you very much for your attention, and I look forward to responding to your questions.
Great, thank you. Yeah, we have 5 minutes for questions from Magali, if anybody has any.
In your presentation, you made reference to noticing with information all the participants as to the volume transaction. But I take it there was no price information commensurate with that volume that was provided them, except for the fact that they paid their bill at the end of the month.
Right, so we had, what we wanted to do is to separate, in order to kind of, to have a clean experiment, one message that provides information about the cost of using electricity, and one message that was relatively kind of, you know, independent from that message about the costs. And so I agree with you that, you know, there is a connection. There is a connection, and, you know, we didn't put the price of carbon, for example. So we did appeal mostly to the kind of the impact on health, and seeing, just to figure out the kind of how these messages would resonate with, you know, the participants. I think providing two messages with two costs in both of them would have been a little bit kind of confusing in terms of how we can disentangle the results. But I agree with you, there is a connection that could be made. Yeah, it's a good point.
How do you tease out for the homeowners the question of a choice of on-off appliances in the home versus whether they're at home at all when you're comparing it to a neighbor? You know, the families that have a stay-at-home parent, where you have to have lights and appliances on, it's hard for them to produce compared to two parents that are always away and you're not using appliances at all. So how do you help homeowners tease that out when they're making their choices?
Well, thank you for this question. It was actually something that you know, we've been thinking about. So far, we didn't provide this information. So the most efficient group was maybe people who were not, you know, at home as often. And we did get some response for families with children. They tended to stay longer hours at home because of the children, you know, especially with infants, they stay longer at home. So that was kind of one issue that we faced, that, you know, how do you figure that? So now we know that we can actually, from the data, we can figure out who was at home and who was not at home from the signal that we have, and we can disentangle that and give more precise information. But so far, what we wanted to do was to get people information. Let's find a reference group of people who are, you know, kind of efficient, and how do you compare to that? So this kind of inflated the efficient group because people who are not home at all, they are very efficient by definition. And so what we are testing right now is what happens if you change the reference group and you give people information about, you know, maybe compared to the average, so that they get more often more positive messages. So what we find out when we looked at the 10% or 20% most efficient, and it's most of the time you're not one of them, right? It's kind of a moving target. And so people like to also get more positive messages. And so now what we're seeing is that you need to kind of maybe have an approach with average and efficient both at the same time.
I have a question regarding your conclusion about the financial message. Were you able to collect any information on which students actually paid for their own rent versus those that it was included in their stipend or their parents paid for it?
No, we didn't get that information. We just assumed everybody was paying for their rent. We did get some information about whether the spouse was working or not, which made we realized some of them actually were making more money than we expected. So we did get that information. We just were under the assumption that they were paying their own, rent. And I think this is kind of pretty accurate, I think.
Very interesting presentation, but I have a two-part question.
Go ahead.
One, the cohort itself is biased in
Yes.
some ways because it's highly educated, and probably we can't take these conclusions and apply it to an EJ community, for example. Right?
what?
To an environmental justice community, low income, low education community. I'm not sure if we can, take the conclusion and apply it straightforward, right?
So what we're as I mentioned before, our population is highly educated. They are graduate students, low income for now, hoping to get more income in the future, and investing in their education. And I think what we found out within this population is there are big differences in how people respond to different treatments, and according even if they have children or no children. So I think what we need to do is to kind of go beyond that and test the same type of approach in different contexts. But what we'll find probably is that it depends on the context as well. It depends on the demographics of the population. But within this population, we did find big differences.
And generally, research shows that highly educated people are, health focused anyway. So you may see some correlations there. And the second question was, when you were talking about the cost savings, the price saving, the second cohort, research has shown that an aggregated savings, people say if you blend your own juice at home rather than going to Jamba Juice, you'll save $1,500 a year. Research shows that that aggregated message makes more of an impact than on a daily basis. So were you showing an aggregated savings? Or
So as I showed there, we did provide the aggregation at the year, for a year. Because we thought, maybe let's try to see how, of over a year, how this number shows. And so we didn't provide on a daily basis. It was over a year. But even then, the number was just small. There's nothing we could do to kind of, we could, over 10 years, you could save $50. Yes, it's just, the numbers we have to work with are small, whether it's on a daily basis, on a monthly basis, on a yearly basis. So.
Great. Well, thank you so much. Our next speaker is Matt Kahn.
Thank you. Okay.
Also, I just wanted to make it clear that we're having 3 20-minute presentations, and then at the end, we're going to have a 15-minute panel discussion with all the speakers up at the front. So if you didn't have a chance to get your question in right after the presentation, hopefully we can get it in during the panel discussion.
Folks, thank you. And so I'm eager to talk about what Frank and I have done, and I will keep my eye on everyone to see if you're as excited about this as we are. So I'm going to be talking about everyone's favorite topic, nonlinear pricing. And so think about your own bill, your own electricity bill. And don't ask me about mine. I think I could have learned from taking our treatment. And so in my remaining time, Frank Wallach of Stanford and I have created a computer software to provide a 20-minute educational experience to make Californians smarter electricity consumers. And we set out, with the help of 2 electric utilities we worked with, to see, can you learn something from 2 nerds if you spend 20 minutes with us? And I'm going to argue that the answer is yes. So folks, our generic question: do California households who live in single-family homes understand how they pay for electricity? Do they understand the increasing block tariff structure for electricity? And some folks are saying no. Some folks are saying yes. There's real tension in this room. And then Frank was very excited. I guess I'm on TV. Frank will see this, unfortunately. We also were interested in the second piece. Do people understand how actions, recharging a cell phone, watching a plasma TV, how that maps into kilowatts consumed? So when you go to Starbucks, you understand what you're getting for $3.35. When we consume electricity, do we know how our actions map into bills and activity? So we had the opportunity, thanks to the Air Resources Board and thanks to 2 California electric utilities who partnered with us, to enroll 2,000 people in the Con Wallach Academy. That was a joke. They took our 20-minute course and they earned their Amazon gift cards. In this 20-minute course, and folks, I didn't mean interaction. That, for the record, says interactive. During this interactive session, we taught households the basics of the increasing block tariff structure, and we're about to go through that. Get ready for some nitty-gritty Econ 101. I was hoping for a cheer. And then we're going to do some simple statistics with the new data we collected to do a before-after comparison. So for the 2,000 households who took our treatment, did they change their behavior? Or did they just keep living their lives merrily? Let's see. Let's find out. So folks, at one electric utility in California, whose name I cannot say, in this blurry picture, do you see 5 steps to the function? So on the vertical axis is the number of kilowatt hours a household consumes in a month. And on the vertical axis is price per kilowatt. Do you see the low marginal price that for those who consume relatively little electricity, they face a marginal price of 12 cents per kilowatt? Do you see that if you are Kobe Bryant or one of the Kardashians, and I don't know where they live, but if you were in the right tail of the distribution, do you see that you might be spending 31 cents per kilowatt? So for this electric utility, there's a lot of money on the table. And so what our field experiment does is it educated each household about, in the summer before they took our course, where did they lie on this tariff? So for example, does everyone see that vertical line at roughly 1,100? This household would learn that they were on tier 4. And what Frank's software taught the household was, if they were to reduce their consumption, perhaps down to 1,000 or 800 kilowatts per month, how much money would they save on their bill? And for everyone who remembers their algebra, that represents the area under the curve. There's going to be a quiz later. That was a joke. And in our setting, there's a fair bit of money on the table, at least at one of our electric utilities. And so the goal of our treatment was for those who we chose at random to participate in our treatment, and then who chose to take our treatment. And I'll talk about the enrollment in a second. We educated them about where their past consumption lied on the increasing block tariff. And folks, a very simple idea from Econ 101. If a household did not know where their consumption lies on this increasing block tariff, and if they now learn they're a tier 5 high marginal price household, what do the dumb economists predict these households will do? Reduce their consumption. And so we're just testing the law of demand, where if our educational experience if they already knew all of this, our treatment should have no impact on their behavior. And that will be my final slide, that what I'm going to show you is, for those households who learned that they're tier 5 households, they reduced their consumption. For those households who learned that they were low consumption, low marginal price tier 1 households, like Magali's finding, they slightly increased their consumption. Now that I've told you the punchline, let me tell you how we did it. So working with one of the electric utilities, and I now want to talk about privacy and confidentiality. One of the electric utilities provided data for hundreds of thousands of households to a third party, not us. We never had access to the names or street addresses of anyone in our experiment. The third party took the data and took a subset at random of these records. And this was the set of households who lived in single-family homes. They then used a random number device to partition households into a treatment group and a control group, like in any field experiment. Folks, we also chose at random an Amazon gift card as our reward for households who took our 20-minute course. We then sent the following letter to households. And I'd ask you, if you received the following letter from Stanford and UCLA nerds, would you take this treatment, and would we select a non-random sample? Dear, insert your name. That was a joke. Utility A is partnering with nerds at Stanford and UCLA to develop a home energy savings workshop. Your valuable input will help Utility A create similar educational tools in the future. This online workshop will take you 20 minutes. We will compensate you with a $50 gift card. It may help you to save money, or it could help you to save money on your next electricity bill. The workshop starts by showing you how your electricity use affects your electricity bill, and the workshop generates customized suggestions you can use to reduce your electricity bill. And then we have an easy opt-in way for how households can participate. So folks, if you received this letter, how many of you would have participated if we gave you a gift card of 0? Minus 50. 30. And so we randomized the gift card. And so the way to read this matrix is the following. You guys are not a representative audience. When we offered the 700 folks who we had randomly offered $10, 4.9% of them participated. When we offered $20, 8.2% of them participated. But notice that the function's getting very flat. When we offered $30, it only rises to 9.7. We were surprised at the low participation rate as a function of money. We thought, as educators, that we're as good as gold. But apparently people are busy. But we thought that this was useful information for how randomized gift cards, if you received this letter, would you really know what your household would gain from this? And so there's interesting issues when electric utilities approach households of what is the expectation of households. And when you offer a monetary incentive, how much does that increase the probability of people participating? So we now have our sample of households who are going to participate in our educational experience. And folks, oh yes, at the electric utility where we offered 0, we had a 6% participation rate, which doubles to 12 when we offered $10. But notice it gets very flat again. So we do not have participation rates of 50, 60%. We were worried we had a self-selection issue of who are the men and women choosing to take this treatment. So we have 3 sets of individuals after we have randomly invited households to participate. We have the control group, who are tens of thousands of households who were chosen at random to not receive an invitation. And folks, we observed their monthly electricity bills. We have the group we've invited to take our treatment who accepted the offer. And there's 2,000 of these individuals whose monthly electricity consumption we will observe for 8 months before the treatment and about 10 months after the treatment. And then we have a third group, this pesky group who we invited, but who declined our offer. And since I'm on tape, I can't call them a word. But it's when an important point for those concerned about selection bias issues. When we graph the empirical distribution of electricity consumption at the baseline, the 3 groups are identical. So there's always an issue. I was a student of Jim Heckman, the Nobel laureate at Chicago, and know his work quite well on self-selection. There's always an issue of, do you have a non-random sample? Who are these folks who participated? But at least based on their baseline electricity consumption in the months before the experiment started, they're identical to the other 2 groups, which gives us some confidence about the findings we're about to show you. I have 3 slides left. So there's a debate right now in economics. Some of UC Berkeley's top economists, Severin Bornstein, Kenichiro Ito, have been writing papers that households respond to average prices of electricity, not marginal prices. And that this has been an interesting literature. We have argued that what Frank and I believe, and we think our experiment verifies, is that when households understand marginal prices, they respond to them. California's electric utilities have complicated bill structures, and households, for whatever reason, until they're educated about these bill structures, are unaware of them. So our experiment is meant to teach households, what do marginal prices for electricity mean? Recall, That was the steps to this function. Here's going to be our key punchline. If you are a tier 5 household, if you face a high marginal price for electricity, but you assume that the average price was the marginal price, then when we teach you that you lie on this 5th tier in this picture, you reduce your consumption after you take our treatment. So folks, here's the key. Let me show you the result and wrap up. So in one of our main econometric tables of the paper, here's what we're doing. We're doing a before-after comparison for the treatment group relative to the control group. And so I want you to focus on the tier 5 treatment because I want to show the ARB how our results contribute to the AB32 efforts. So folks, take a look at that coefficient of minus 1.201, and let me explain what that is. And I just have one more slide after this. For the set of households who in the base month, in the summer before we started our experiment, for those households who were on the 5th tier for this electric utility, so recall that the 5th tier is to the far right, facing a marginal price of 31 cents per kilowatt. What we find is this. Relative to the control group here are the set of households who were also on the 5th tier but did not take our treatment. So again, relative to other households who had been on the 5th tier at the baseline but did not take our treatment, the treatment group on average reduced their consumption by 1.2 kilowatts per day after taking our treatment. And folks, the important point to note, if you compare the tier 5 coefficient to the tier 4 treatment effect coefficient of minus 0.912 to the tier 3 coefficient of minus 0.461, what to infer from these results is the higher the marginal price you face, the more you reduce your consumption when you learn that you face this high marginal price. AB32, one tool in the toolkit for achieving AB32's goals is to educate more tier 4 and tier 5 households, and I would say commercial consumers as well, that they're out there in the tier and how much electricity consumption, how much money they could save if they reduce their consumption to move to a lower pricing tier. Final slide. So thanks to Frank and Stanford's work, we now have this software, and this software can be used again and again. Our challenge is to roll this out again, we need to partner with California electric utilities. We found these utilities to be nerdy, but to be very busy. And I think that Sacramento moving forward has to come up with some sort of nudge or incentive to create incentives for the utilities to talk to the nerds. They're very eager to talk to their own private consultants, and some of these folks are great. But of how we're more likely to achieve AB32's goals if the nerds and the utilities can be brought together. And to come back to something Magali said, as we're rolling out the smart meters now, they're more likely to be effective technology with smarter people and our people who understand the technology and have some energy IQ for how to work with this equipment. So this interface between engineering and behavior, I think, is a very important aspect. The engineers need the social scientists and vice versa. So, thank you.
Great, thank you so much, Matt. That was a great talk. But actually, if you want to stand up here for a couple minutes, we could field a few questions if there are any out there. Sure.
Hi, in terms of magnitude, what percentage of people falls in the tier 4 and tier 5? Only 20% of the electricity consumed by consumer. I assume that only a small percentage of people. What impact is going to have on energy use?
So you're right. So I'm a microeconomist, so I agree with what you just said. So if you look at these 5 tiers, again, as he just said, there's a relatively small share in tier 4 and tier 5. So you are right. From any microeconometric result, how does this move the Rosenfeld curve? And I would say it moves it a little. And it's a very fair comment. But there's always a question how you move to macro from micro. But I would say that the more the merrier. I would want to educate all the tier 4 and tier 5 households, and that would make some contribution to reducing aggregate residential electricity consumption. And I would say one more thing. Our experiment ended after 12 months, in the medium term, do households who learn that they've been on the 5th tier purchase more energy efficient durables? What are medium term adjustments they make? And so the treatment effect we reported is a short run effect. There's interesting questions of how households change their lives in the medium term. So if I had to punch back, that's my slight counterpunch.
Small question. Did the tier 4 and tier 5 customers who it looks like maybe have saved around 30 kilowatt hours a month, did that bump them into the lower tier, generally speaking? Or do you know if that had that effect? Because presumably that was the marginal goal here. It wasn't just to use 27 fewer, but enough fewer to bump you into the next tier.
So you're right that I like that very much. So a point that Frank kept stressing in my discussions, with our discussions, is just what Ruben just said, this goal of moving down a notch. I'm looking at the area of these rectangles. So I agree with you. In our current draft, we haven't done enough on that, and we should.
What was the average kilowatt hours per month used by those who dropped down by 1.021 kilowatt hours a day?
So these guys, so you need to read the base here. So down at the margin, that this is at, I'm reading 1,400 down here. Maybe this is hard for, so we need to divide that by 12. And that, or I'm not doing my math right. So this is per month. And so these guys are above 1,400. So if it's a uniform distribution, it's 1,600 per month.
So that would be a drop of 31 kilowatt hours.
Yes, so on a percentage basis, this is small, but this was a 20-minute course. This was not going to UCLA and spending 15 grand a year in tuition. You just listened to me speak for 20 minutes. So there's a question, what in any 20 minutes do you gain? And so I understand where you're going, but it was a 20 minutes well invested. So I'm not going anywhere. But again, if this information was all redundant, this coefficient should have been a 0. When is information, to an economist, if there's statistical evidence of a behavioral change, that means the information is new news. And that means that there's a cost to the current complexity of California's bills. I understand we have the increasing block tariffs to help poor people, to protect those in lower tiers, but an unintended consequence of the complexity of the bills is perhaps we're not achieving all the efficiency we could. And so our work speaks to unintended consequences using a field experiment design, and this is how new knowledge is yielded. I would not say that this is the cure-all for achieving AB 32's goals, but it's part of a portfolio of strategies. And it's low cost. Now that we have the software, this is very low cost to implement. For those households who signed up for a 0 gift card, the marginal cost is 0, except for their 20 minutes.
Can we experience a 20-minute treatment or class?
So yes, my co-author, I would like to make that link available. Now, it has to be customized for your electric utility because the block tariffs will differ depending on your electric utility and where you lie on the schedule. But we would love to roll this out for each of California's electric utilities. And some of my colleagues at UCLA have been taking our course on their own. These are super nerds. Without an Amazon gift, with an Amazon gift card of 0.
Great. Thanks so much, Matt.
Thank you.
Our next speaker is Ruben Doimling.
Well, thank you. I'd like to start by thanking the Energy Efficiency Center at UC Davis, who were the coordinators of this research and helped manage the project. The title of my talk is Exploring Very Low Energy Consumption Rates in Urban California Households. And there's one key difference between the talks you heard and our talk, and that is that we looked throughout the research at the variation, the differences across households. So the average was not really our focus. Going to look briefly, ask the question, why study low electricity users? We'll spend a few minutes on methodological questions. Most of the talk is going to be on the findings. And then we'll wrap up with a few thoughts on how insights about low usage could inform policy that we've heard a little bit about already. So why would we study low users? As we've heard, greenhouse goals translate to a required 80% reduction in emissions by 2050. And some of the anticipated way of getting to that goal will be through shifting in the supply toward renewables. Aside from those shifts, is it conceivable that Californians could live with 80% less energy? And the answer to that is also our research question. We would like to find out if there are households that operate at that level and what we can learn from them. So this is the plot of the distribution of electricity, residential electricity consumption in the SMUD, Sacramento Municipal Utility District territory. And this is the mean of the consumption, the 50th percentile, and the 10th percentile. And in this talk, I'm going to be focusing on this section of the distribution, which is the lowest quartile, and actually mostly on the lowest decile. So the people who use less electricity than 90% of the remaining utility customers. And this is the slide that expands that shaded bar before. We see here the lowest quartile, so the bottom 25% of the population in the SMUD territory, split up by renters in the light bars and owner-occupied households in the dark bars. And on the far right is the 25th percentile, then there's the 10th percentile, and the red dashed line is a heuristic, and it's important for this research. So I'll glance at my notes. The right page. If we conceptualize the 2050 goal of Executive Order SO305 as reduced consumption with the current energy mix, this would correspond to the dashed red line. And in this research, we want to know what people at or near that consumption level are doing. And so we focused on everyone to the left of the 10th percentile in this research. Moving on to why we might study low users. Although low electricity users have actually almost not been studied at all, it isn't hard to find opinions about what sort of people use very little electricity. Typically, the study of energy or any other phenomenon is examined quantitatively with a focus on averages, average usage, average income, average household size, and so on, which tells us something about the population as a whole, but it gives us no insights into the degree of or reasons for variation. Why or how some people manage to live with very little energy or get by without a car or any of the other possible outlier behaviors we could look at. The social, economic, and demographic diversity we discovered among the lowest decile of electricity consumers is obscured by attention to the statistical fact of a lower average income or household size in this subpopulation. And I'll say more about that in a few slides. Our sampling methodology, we looked at customers in the lowest decile, and we removed, or the utility removed, recent movers, and we removed unoccupied households, or households we suspected based on their usage patterns were unoccupied. The three bars you see, the maroon bar is the renters in the lowest quartile, the 25th percentile again on the right, down to the 1st percentile. The blue bar are homeowners, and the yellow are the ones that were removed by the utility because they had moved sometime in the last 36 months. So those we never saw. And our focus, again, is on that section of the population. So owners and renters who had stayed in that same house for 36 months or more. And the small bar on the left was a cutoff we just created beyond the algorithms for who might be which households might be unoccupied. So we cut it off at 45 kilowatt hours a month. And here is just a very brief view of the data fields that we asked SMUD to supply for those households, those 27,000 households, which represent the lowest decile. And I'm not going to spend a whole lot of time, but I'll hope to explain throughout the rest of the talk something about those data fields. But there's lots of demographic and other detail about the customers. So moving on to our findings. We got a very respectable response rate, 720 return surveys out of just over 4,500 that we mailed. And one of the key findings of this research was that the population in the lowest decile was a heterogeneous group from all walks of life, measured by income, age, race, education, the size of their house. By those measures, they were quite similar to the general population, as I will show. So I have one slide here on income. There are other slides we could get about other of those categories. We have here a little small sets of 3 bars. The left dark black bar is the total utility territory, income distribution of the total utility. The middle bar, the lighter gray, is for the lowest decile, the 27,000 customers whose information we got. And the bar on the right is the results of our survey, the responses to our survey questions. So it measures the degree to which we were able to capture, in this case, income through our survey. So any difference between the middle and the right bar is due to our sampling errors. A surprising finding, low users own slightly more appliances than those who are not in that tier. And this is a slide that shows central air conditioners, clothes dryers from left to right, refrigerators, stove, swamp coolers, and window air conditioners. On the left is the total SMUD population, and on the right are the survey respondents. The top is owners, and the lower section is renters. And we found a very similar distribution for home electronics as well, that there were slightly more, slightly higher saturations of appliances among this population. And we compared our findings to the RAS, the Residential Appliance Saturation Survey that the utility put out in 2008. It turns out most low users are not poor. We came up with 6 hypotheses that guided this research, and I'm going to briefly talk about 4 of them. Most of these arose in connection with those common beliefs that we started with, that low users were poor and lived alone and so on. The first hypothesis, people use much electricity because they are poor. Here is a slide of income distribution for both owners on the left and renters on the right. And those are bins of income below $20,000 on the far left, all the way up to above $200,000 a year on the far right. The majority of households in the lowest decile are not poor renters. Homeowners in the lowest decile are normally distributed about the $50,000 to $100,000 bin, not so different from the general population. And renters, though they are more evenly spread out across the 4 bars on the left, this is not so different from the population in the general population. On the other hand, do low users live alone? The assumption here was that they do, and we found that on average, a high percentage do live alone. 60% of homeowners and 70% of renters in our sample, which corresponds to a 1.6 person per household average in the sample versus a 2.6 person per household average for the county as a whole. Although about 1/3 of low users are not single person households, the balance is off enough for us to accept the null hypothesis in this case. But before anyone discounts the policy relevance of learning that many of the lowest electricity consuming households in Sacramento are single people, it's worth pointing out that 3/4 of the single person households in the SMUD territory are not in the lowest decile. So about 100,000 households are occupied by one person, but they are not found in our sample. So they're above the 10th percentile. Looked at household size, the assumption here being that 70% or more of the lowest users live in small apartments. And here we have another of the same kind of a comparison set of charts. The average size of an owner-occupied house is at 1,250 square feet, which corresponds very, very well to the distribution we found in our sample. For renters, the peak is in the 500 to 1,000 square foot bin, but because we asked the question with such a large size of bin, we can't say exactly how much the renter population is or is not different from the general mean in the population. So we rejected the hypothesis partly because, in large part, because of the fact that roughly half the population are owners, and for them the fit is very good, the similarity of the distribution. Low users also use less natural gas. There was a hypothesis that people who use less electricity are in that category because they substitute gas for domestic appliances. So if they have more gas appliances, maybe they have a gas water heater versus an electric water heater, that would be an easy get out of jail free card. It could easily put them there without them necessarily doing anything differently or taking credit for it. We got aggregated monthly gas bills from PG&E. That was all they were willing to give us for both summer and winter. And comparing the two, we see the dashed line is the average bill for all the customers. On the left, we have summer, and on the right, we have winter. And then we have a distribution of gas bills as reported to us by our survey respondents. And here we see that the gas bills of those who responded to our surveys were markedly lower in both summer and winter. So we reject that hypothesis. Moving on from our hypotheses to more qualitative questions. Because the study was conducted in Sacramento, which, as we all know, is a warm place in the summer, air conditioning was a big topic and something we talked about both in our survey but then at greater length in our interviews. We asked people if they have AC, air conditioning, how often they use it. And it's a little hard to read, but we have a set of bars going from never on the left to very often and other category on the right. Owners on the left, renters on the right. Comparing that to income as mapped onto households who do not have or do not use air conditioning on the second chart. 38% of households who responded to our survey fit in either of those categories. They do not have AC, or they have it but use it only never or very rarely. So the homeowners are, again, normally distributed about the 50 to 100,000 bin. And renters, again, a similar distribution that we've seen before, fairly evenly distributed over the first 4 income brackets. So if we had been inclined to assume that AC non-ownership or non-use was associated with not being able to afford to run it, this chart suggests that it's more complicated than that. There are a lot of people who have no income constraint who are not using AC or do not have AC. So I'm going to go through this pretty quickly. 70% of respondents indicated that they had done something to reduce their energy consumption. Thank you. 65% of owners and 54% of renters indicated engaging in one or more of what we call thermal management strategies. I'll go through this really quickly. This is something that was not on SMUD's list of actions. It was opening windows to let in the Delta breeze. The second most common for renters, the fourth most common for owners. Here is the most common strategy for both categories, what we call judicious AC use, which had to do with high thermostat settings or explaining how rarely they would use their air conditioning or when they would turn it off. And the blue arrows point to no AC usage in the questions that we drew on for this table. Right along. So this is a slide that it would be fun to spend a lot of time on, but unfortunately we won't. The idea here was to organize the responses we got from lowest users about their actions. From left to right, we go from the general to the specific, and the effect is on the far right, the result. The parameters are conceptual categories. The principles, operationalize these and apply them to a set of domestic circumstances, a question, a challenge. And then the examples, of course, are the actions. At the bottom, we have, there's 4, space, time, sufficiency, and efficiency are ways we grouped those actions. And there's other ways one could have done this, but this was how we approached it. And the distinction I'd like to highlight here between sufficiency and efficiency is that the sufficiency includes typical manual, behavioral, or self-generated actions, and asks, can I simplify this task? Whereas efficiency relies more on experts who supply a technology or hardware, which an individual may adopt through purchase. And the scope of the task is usually not questioned. Both can yield similar results, but they're otherwise quite different, and the degree to which policymakers have been comfortable dealing with those two categories, as I'm sure many of you know, can be starkly different. I'm going to skip over the next slide. Finally, we decided to group our low users in a variety of ways that we called profiles. Categories that would be recognizable, perhaps evocative, and that highlight particular dimensions of the people in this group. And that could communicate the diversity of people in this population. And all but the last category, which we call unhappily low energy, were emergent. Unhappily low energy reflects that common belief that people are unhappy and not there by choice. And these are the 6 we settled on, and I'm going to talk a little bit about the first one. Well-off and energy efficient was generated by these criteria, which we used by drawing on both the quantitative and the qualitative answers to our survey. Quality of life, education, income, home size, ownership of a broad sweep of appliances, and have taken some action, identified an action or multiple actions on energy efficiency. And the 6 profiles that we generated are not mutually exclusive. They overlap to some extent, which is not an oversight, but suggests the heterogeneity of this population. So for instance, in the well-off and energy efficient column on the far left, a subset are found in the ultra-low group, which is the group that's most closely allied with that 2050 target, whose consumption is at about the 3rd percentile. And I'm sorry I have to rush through this, but this is my last slide. So the question here is what kind of conclusions we can draw from this that might have relevance to policy. So identifying low users, understanding them, and describing them was the chief and primary purpose of this research. But we also wanted to take this another step further to suggest approaches to reducing greenhouse gases, a way to operationalize this. The knowledge that low usage is real and those who use very little energy are a diverse bunch is a good start. And being too poor to afford more energy is true for only a minority of low users that we surveyed. Crucial, this is an important point, because the differences between the low user population and the general population is smaller than we may have thought, socially, demographically, and perhaps motivationally, but that's an open question. The challenge for us is not to necessarily convince the rest of the population to do X or Y, to invent strategies that may or may not work, but to demonstrate and communicate examples in the real world of low usage in a way that people can hear and appreciate, to show that there are people perhaps much like them in this low or lowest tier. whether unconsciously or unconsciously, individual actions and a little initiative go a long way. There's no way around the fact that many of the people, the majority of the people we interviewed had taken some initiative, had adopted this as a project, had found something about it important enough to sort of run with it. And finally, I'll end with a question. We don't know the extent to which the invisibility or the misunderstanding of low usage is presently a barrier to reducing one's energy consumption. There are lots of reasons why people end up using as much or as little as they do. But the question that presupposes is whether revealing the existence and diversity of low usage could open up new conversations, new ways of thinking about and tackling this subject. Could it give permission to take ownership of one's energy consumption in a new way? We think so, but the challenge is to take up the insights from this research and other research into the social context of energy use and incorporate them into outreach campaigns, creatively use what we're learning here, the specifics, to explore this topic in a public way. Thank you.
Great, thanks, Ruben. Are there any questions for Ruben?
You said you accounted for house square footage as a general. House square footage is a general general variable. Did you look at some of the more detailed elements that are important in this climate, like shading and orientation and the facility of the building for cross ventilation, especially in looking at the very low users and the unflappables?
Yes. Qualitatively, yes. We did not think of a way to, we didn't have a data point in our sample of data from the utility that measured that. It, however, did come up in response to questions we asked. And so going back a few slides here, whoops, this might or might not work. Here, we have 12 thermal management strategies that people said they engage, 12 groupings of management strategies. And a lot of those deal with the location. They sort of try to work with the location, improve it. And so we have insulation, weather stripping, open windows, shade trees, window shades, double pane. A lot of windows, I didn't talk about the windows management, but it was a very big category for people, and certainly was a topic that people had identified themselves.
On this topic, you identified this open window delta breeze as an important thing in this region. Could we use this to inform the CEC and the incentives programs that the encouragement of what are called smart vent systems for houses in this region would seem to be a very important step one could take, because the other households that don't want to run around and open their windows every night and close them in the morning and put up fans could flip a switch and get the same benefits. But we've, over the past years, underfunded or incentivized people to install those systems. So it would seem that one of the key findings of what you've come up with is that we should rethink that and help you give out money for higher efficiency air conditioners, but frequently we give nothing to install the automatic.
I would say two small things to that. One would be, yes, and bundle it with the message, carefully worded perhaps, that there are people who are achieving the result we think you will get with this device manually. And secondly, building on that, present the two as two sides of the same coin. In other words, there's the device option, the device rebate option, and there's the manual option. And neither of them are speculative or something we feel we know will work, but in fact we have observed to work, or at least to correspond to usage that may be lower than we realized our neighbors or members of this audience might actually use.
And then there's also health benefits when the smart vent systems filter the air that comes in the house, the other ones don't. So there's other allied benefits that could be bundled up in this.
All right, one more question then. Actually, if the speakers want to move up to the panel, that'd be great.
I know you said that you didn't look as much at the motivational aspects of this as you might like to. But do you have a sense of to what extent the folks who had energy efficiency in their profile were motivated by utility rebates or state programs, et cetera?
There was, I'm going to waffle on the specific question, but there was a surprisingly good correspondence between a lot of the strategies that people identified and what is found on SMUD's very extensive list of actions that people can take. Now, people did far more than those things, but the extensive list was well matched to what people identified. And I wasn't familiar with that SMUD list initially and thought, oh, these people are so creative, this is fantastic. And then I found a lot of them right there on the website, which says something about this particular utility's approach, that there was, I think, a greater attention to the specifics of doing that. But I don't specifically know the answer to your question beyond that, and the sense that there is both a diversity in the official recommendations and an even greater diversity on the part of the public taking them up and running with them and expanding on them and going beyond.
Great, thanks, Ruben. So I was hoping that since there's so much overlap, obviously, between all of these presentations, if you had questions that you want to address to all the speakers, and maybe we could even talk about policy implications and also research going forward as well. But are there any questions to start it off? We actually did get one from the web for all the speakers, and the question is, did you quantify the numbers and impacts of solar water heating and or solar PV panels?
I can say something small to that. In our, push. Yes, that's good. In my mouth. In our survey work, we specifically removed those who had renewable energy systems. And the reason for that was not that we didn't appreciate their doing that, it was that in a way it was another get out of jail free card. We wanted actions and not something that was a big purchase to qualify them. There were people in this tier whose usage we could see over the years had dropped dramatically once they installed. We had the date of installation of their solar system, PV typically. So we specifically did not look at that group.
So in another paper of mine, we took a look at, am I on? We took a look at the resale value of homes with solar panels in 2 parts of California. I'll turn to the audience. What's your estimate? Both we found 3.5%. So the same home with solar panels sells for 3.5% more. So a $400,000 home, my math says that you should add 14,000 to that. So this was some work on the capitalization effect of green investments. And there were folks who liked that result. And I think we're going to see more work on this result, but we were not paid for that result. And that was from 2 California counties, one of which was San Diego and the other which I can't name.
Is it Magali? Mm-hmm. You showed, I'm really curious about when you broke down the types of appliances, you had an other category that was as large as 8 to 11%, and I'm trying to figure out where that would be if it wasn't a plug load. Where is that unknown electrical appliance?
This other category relates to the kitchen. So what you have plugged on in the kitchen, so that would be the microwave, that would be your toaster, the rice cooker. I don't know. Can think of a mixer. I mean, all kitchen plugins, and actually they happen to be quite to add up. Yeah.
Courtney.
So my question is actually for Matt and Magali. So Magali, it looked like when you guys gave high-end consumers information about their usage and like in terms of the cost message, how much more they were spending compared to the average user. it didn't have an impact, or in some instance maybe even increased their usage because electricity was so cheap. But then it looked like Matt's finding is that high-end users, when they're given cost information, specifically information about the marginal price that they're paying, they're decreasing their energy use. So I'm just trying to piece those two things together and wonder maybe what the take-home is. Maybe it says something about the fact we need to increase our per unit price, but I'm wondering if you have any other ideas or thoughts about how then cost information should be used moving forward.
So you heard us correctly. And so it's 2 points. Our populations were different. While in my population were single-family homeowners, and we were in a different electric utility nearby, but different electric utility, and the marginal price on the 5th tier was 31 cents. And so I think this, as social scientists, I think one of the themes today is, I wouldn't call this a bias. I think in a world of diversity, we estimate different effects for different groups under different circumstances. And economists are not physicists. And so I think I'm very comfortable with learning about different populations. But again, the way I'd reconcile our results is the consumers in Wallach and my study were single-family homeowners and facing what I believe are much higher prices than in Magali's, but I will leave it to the boss.
So I think what our population, so these are 1, 2, 3 bedroom apartments, the average, I think, electricity bill is $50. So the high, user in our case, maybe it's $150. It's still relatively, in fact, a relatively low user. So we had a focus group afterwards and asked people, so why did you see when you saw this? And they're like, we were surprised. We didn't think that, electricity was so inexpensive. And, in the end, we just realized we could, kind of spurge. We could just enjoy, our AC, full time. So I think it's just a different population and distribution that we have.
Yes, I wonder whether the allocation, tier allocation for some people are different. Like people who use the medical devices, for example, they get larger tier 1. So did you correct adjusted those for those people? I don't know what percentage of people using medical devices.
So you are correct. In my study with Wallach, we dropped such individuals. We asked each electric utility, for the bulk of your single-family homeowners, what is the major pricing system that the typical person's on? And in our randomizations, we only focused on those subpopulations. But what you said is correct. But we, anticipating that, we focused on a subgroup, the most vanilla of the subgroups, the most typical of the subgroups.
Are there any questions from the audience? We did get another question for all the speakers from the internet, and that was, do you survey whether or not you were collecting information from different political parties, or how much of a difference do you think political affiliation makes in terms of influencing people's behaviors?
I could say something about that. No. The short answer is no, we did not. We weren't particularly interested in it, though it is, I think, becoming more and more common to do that, and in the course of trying to segment a utility's population for various reasons of outreach, reasons of messaging. I think that's becoming more common, but we had no interest or desire to do that.
So we didn't collect information about political affiliation, but we asked people about their preferences for the environment, and so we had these psychological scales where people kind of position themselves in terms of whether they care or not about the environment, how altruistic they are, whether they belong to an NGO, and so we found out that people who belong who are part of an NGO tend to use less electricity. So we try to control for the ideology in that way, and we still did find our differences. The results are robust to this controlling for these differences.
So in our study, short answer, no. The power of randomization is you take the set of all single-family customers who are on the standard pricing tiers, and then you randomize them into a treatment and control group, and presumably there's a balance that on average similar groups are equally distributed across the treatment group and control group. So our study had no link to political ideology or to some of the ongoing issues in our country today. This was about, do people respond to marginal price information? End of story.
Oh.
This is mostly for Ruben, but I'd actually like both of you to, all of you to respond to it. It's about the idea of engagement, that there are, I mean, if you're attempting to try to measure something demographically or using attitudinal approaches and that sort of thing, you're coming at it by saying that if they are politically affiliated or if they've had this experience or they're part of this demographic group, then let's see if we can associate that with the behavior. The underlying premise of that is that maybe we can engage them somehow by targeting our marketing or whatever at that demographic group. If you come at it from the other direction, and in conducting a study you find, as Ruben found, that there are people that seem to be engaged with saving energy. In other words, they're trying to do it. You found a subgroup of people that's part of this low consumption group, some of whom are not, but some of whom are, who are engaged with the idea of keeping their energy bill down or their energy consumption down, and so they look for things to do about it. Can you think about ways to move on from here, both from, say, Matt's perspective, using an economics framework, or from your perspective, using this sort of subgroup framework, to try to find out how people you identify by these studies do these things, and then try to expand from there in terms of giving us in the policy world something useful in which to build programs around. When you say low users use less energy, what can we learn from them, and how do we find other people like them who may not be as successful as these guys, but who are still attempting to do it and giving them the tools to do it?
Well, thank you for that question. I like it very much. I would answer it by focusing on what I like to call giving permission. That in the current landscape of outreach, as I interpret it, we don't tend to focus on giving people permission to run with this. We prescribe strategies, purchases, products, but I don't see this kind of vernacular behavior or even following official instructions as being on an equal footing. So my response would be, we haven't tried it, I don't think. We haven't given it much airtime to invite people to take this seriously, to try this for themselves, to appreciate that their own actions might yield an effect greater than what Magali found of $26. That there is a potential, and I can't parameterize what the potential is, I don't know how to do that, but that is a potential that people could see that message and feel invited, feel like they have been given permission to run with this, or validated. We don't know. I mean, there's lots of other people we didn't reach who may also be doing this, or whose usage may be 11th percentile or in the first. We don't, there's lots that we don't know, but I feel like if we were to include what we found in an outreach campaign, that the potential for people to run with it is potentially considerable. I don't think we know fundamentally, but I feel like based on how we heard people responding to our questions in a variety of different registers, it seemed like the reservoir of interest was considerable. Does that speak to your question, or is it?
So,
seems like going iteration 2 of your study, presuming there would be additional funding, might be to look at people in the middle range, from 25% to 75%, and try to figure out a way to have them self-identify as the same group of people who were trying real hard and were successful in the group that you observed, and then try to find out what the barriers were to them being, I hate that word, by the way, but the problems they were having, or the inability to follow through on what they were trying to do, and find out if there was a program, and that might give information on coming up with programmatic ways to help them achieve what they're already trying to help, rather than spending a bunch of money trying to motivate people to do something that they don't necessarily want to do.
Right. So I think, I mean, to respond to some of your question, what we try to do by comparing people to the most efficient in their complex is to say, you know, look, there's a benchmark. People can do it. These are people who do exist. These are your neighbors. So you can be like your neighbor and be, you know, as efficient as them. They're an example. So this is kind of what we try to do by providing this comparison with the most efficient, not the average, the most. I mean, really, the best you can do is available. And so I think that's the first thing, is the benchmark. The second element of that is, how do you connect to them? Do you know them? Do you know what they've been doing? And so in a previous experiment, we had tried something else, which is we had, these were in the dorms with students, so we had this, what we call this private information, this website we provided to people, like this, similar to what we've done here. And then we had this public information that was provided in public, saying, look, this room is efficient, and this is your neighbor, and you know him because this is his name on the poster. And so basically what we've done is we had provided, you know, green dots for those who were using electricity below average, and red dots for those who were consuming above average. That was with you know, undergraduate students. But the idea is, you know, maybe there's a way also to use information and disseminate good practices, best practices. And we haven't, and that's what you're describing, all these best practices. And we didn't know ex ante that, you know, these people actually thought about it and were doing all these things. How do we diffuse that in a kind of a public way? And I think one way is to say, you know, well, you know, compare people to this benchmark, and then publicly somehow praise, you know, this, low users.
I want to add two quick thoughts on this, and this is something that Susan Fisher and I, at the start of this project, in my discussions with the Air Resources Board, were discussing, that for households, for those in the treatment group who took my educational course, what Frank and I put together, for those who had a good experience, would there be a way to use Facebook to spread the word within social networks? So while electric utilities know much about their customers, perhaps friends know more about the personality and attributes of friends. We ran into some privacy issues and more headaches. I lost some of my hair at this stage, but it was very interesting to think about, and we didn't pull that part off. But I'm very optimistic that a friend tells two friends who tells two friends, that for the subset of people who benefit from one of these educational experiences, there's the opportunity for social learning. One other point. I spent a couple of moments in my slides. Do you remember I said that even when we offered guys $50 for the Amazon gift card, and that was tax-free, we couldn't get 20 minutes from them? That identifies those subgroups as folks the electric utilities shouldn't go back to. Contrast that with the groups who, when we offered $0 or $10, they participated. While I don't know their names for privacy reasons, the third-party data vendor we worked with could give those names back to the electric utility, and that might be low-hanging fruit to approach about future energy savings programs. These men and women might want to go on for the PhD in energy efficiency beyond our 20-minute GED. And that, so it's identifying certain subgroups of the population where I think academics can be useful, of getting beyond averages in a diverse world. How do we find the low-hanging fruit while respecting privacy and engaging in cost-efficient targeting?
I have two linked questions. First of all, assume I'm a legislator or a regulator or something like that, and I want to use your research and make some sort of regulation or implement some change. What would you do? what would you say? What kind of legislation or action could I take to benefit from that benefits from your research? And the second thing, which is linked, believe it or not, is what future work do you need to do, or would you recommend based on what you've done before so far? I've got all afternoon.
Do you want to?
Oh, I'll say a little bit. On the legislation question, I would jump to the side a little bit and point to contests and competitions and invitations again that wouldn't need to be legislated, but that could be inspired in a similar vein, that we open up this black box of average consumption, which I think, in response to David's question, I think too many of us assume, without having asked the question, that our usage is much like our neighbors, when in fact it may be vastly different, higher or lower. And I think opening that up, inviting people to discover how far they may be removed, and of course that can backfire if they're higher than the mean, or if they're lower than the mean and they use more. I'll punt and come back to the future research.
So, Alan, one point that I would make is, again, the value of information. So the key punchline Wallach and I take away from our study is that you can change California households' behavior with information. Currently, there's some confusion and a lack of information about the increasing block tariff. With the smart meter rolled out, and I don't have one in my house, but as I understand it, households will be able to run their own experiments and see real-time information of what marginal price they face, especially if they opt into dynamic pricing, critical peak pricing, and they can run their own experiments of turning on a dishwasher, turning on their plasma TV, and seeing how much their electricity consumption and their bill jumps. And as economists are always optimistic that we can change our game, but a necessary condition for adapting and responding to price signals is that you understand the prices you face. And so we think our work signals to legislators that single-family homeowners are adults who, when folks understand the incentive structure they face, they begin to change their behavior. And so perhaps you don't need to shield these individuals. So in the future, if California, there's a question, how will when more households are exposed to dynamic pricing, will they suffer greatly, or do they have an elastic demand for electricity? And we are more optimistic, perhaps, than others of the responsiveness of the population in the short run to when they understand marginal pricing, that we can expose. So one policy answer is we can expose more households to dynamic pricing, that in the short run they respond, and surely in the medium term and the long term, when they have more time to adjust, will they see even greater ability to cope with being exposed to prices that reflect true scarcity.
To build up on what Matt is saying, I think information can be extremely powerful. Here we've seen research that shows that people respond to information they didn't have before. They are learning, they are conserving. This being said, there is still more research to be done. We see that it depends on the context and that information can be framed in different ways and the results are very different. There is an enormous amount of data that is gathered by the electric utilities. It is extremely difficult for researchers to have access to this data and work with this data. I think we do have the tools now to do very rigorous research that can inform policymakers, but it's been just difficult for us to get some of access to this data. So I think more transparency could be helpful to us anyway for this research.
Great. I'm sorry for lack of time. We have to finish. I think that was a great question to finish on. And these were all great presentations. Thank you all so much for coming to California, or to Sacramento, and Reuben to California. And as I said before, the final reports from these 3 projects are now available online, so you can go see those, and you can go back to their PowerPoint presentations if you have questions. And I think they might be lingering around if you have additional questions as well. So thank you all for coming. Appreciate it.
Thank you.
Sure. Well, concerning your work.